Hello everyone, welcome to my YouTube channel. So today we are having a topic of Java called as platform independent. So it is the biggest feature of Java for which Java is popular. So what do you mean by platform independent? In order to understand this, first we have to understand what is a platform. A platform is the place where codes or programs resides. That means what we can say, it is operating system. And nowadays devices, because nowadays we are having the smart devices, they are also capable of executing the program. That means we are saying more or less Java is operating system independent. How? If we can simplify this, its meaning is Java can be executed on any kind of operating system. That means we can run Java in Windows, Linux, Mac, etc. Whatever operating system exists in the world. But what is the new thing, boss? You can ask me that C, C++, and other languages, they are also getting executed in Windows, Linux, and Mac. So what is the speciality of Java? Because C and C++ we are not saying as platform independent, but whereas we are saying Java as platform independent. What is the reason behind it? We have to do some analysis on that. Let's understand C program execution. Suppose I have to write a program in C, C++. Let's say I will give the name as hello world.c. Okay. So whenever you are writing the program, we are writing in which language? We are writing in English, right? English. Because it is human understandable and we will be writing program in English. So which is nothing but called as high level language, right? But from the very beginning, when we understand the computer, we know that computer understand a kind of language which is called as machine level language, machine level or machine code or machine level language, right? So what is this machine level language? Generally it is zeros and ones. Machine doesn't understand English. Machine only understand binary, and which is called as machine level language. So then we can say then we are writing English, but machine is understanding its own code called as the machine code. So how this can happen? That means suppose we'll be speaking to a Chinese person without knowing Chinese. That means we need a translator which will convert English to Chinese and vice versa. So in technically that is what is called as compiler. In technically that is what is called as compiler. So what is a compiler? This compiler is a translator which translates high level language or program English language to machine level language. Then your operating system can easily understand and gives you output and gives you output. This is nothing but your operating system. Now let's say I'm executing this program in Windows machine or Windows operating system. Now let's say I want to execute the same program in the Linux platform or Linux operating system. Then what we can do? Simple, the program will remain same. The program will remain same because all program maximum programs are portable. Almost all programs. Portable means changing the platform or operating system doesn't impact the source code. We don't have to change single line of the source code. Then same thing, it is what? It is high level language or English language. Then what we need? What we need? Now we need again compiler. Compiler. Again compiler converts to machine code. Then your operating system executes it to give you the output. To give you the output. This is OS, operating system. OS is nothing but operating system. Operating system. Okay. Now, there one thing to understand. This language is same, irrespective of the operating system. It may be Windows, it may be Linux. This language is almost same. And then output is also same. Suppose I want to print even numbers between 10. Windows will also print 2468. Linux will also print 2468. That means this language is same and this output is same. But what about this machine code? Is this machine code for Linux and is this machine code for Windows? Both are same or different? Of course, that is different. That means the compiler for C or C++ is platform or operating system dependent, and hence their installation and hence their installables are also different, right? That means the installables or softwares are also different. That means for Windows operating system, your C software is different, C++ software is different, for Linux different, because their compilers are different. So that means whenever we change the operating system or platform, we need the compilation of the code in order to get the machine code of their platform, right? Now we'll see how Java will deal with that. Okay, suppose we'll write a program hello dot Java. So each Java program is having the extension .java. Whatever program will write, its extension will be .java. So similarly, we are having hello.java file with extension .java. Of course, we'll be writing in English. So it is, you can say, or high level language. English or high level language. Okay. So that means this English or high level language is not understandable by the computer, by the operating system, because it is English, right? Then what we need? Simple, we need the same thing called as compiler. Okay, and here after compilation, Java compiler produces a new kind of file which is called as hello.class file. And if you know C, in Windows system, after the compilation, it generates some kind of file called as hello.obj. It is nothing but the object file which contains the machine code. We can open that file, but we can't understand anything. Similarly, here you can open the hello.class file, but they are coded files. We can't get anything. That is for understanding of a different person, which is called as a JVM. We'll come to know that. So it is hello.class. So this .class file actually, surprisingly, not machine code. That means this is strange thing. In C and C++, whenever we compile the program or code, we get directly the machine code which operating system understands. But here in Java, if we compile the source code or the application or the program, it creates a kind of file which is not machine code. That means you can say, are you saying that it cannot be understood by the operating system? Yes, it cannot be understood by the operating system. This compiled file or dot class file cannot be understood by any kind of operating system, hence can be executed. So it is a kind of code which is called as byte code. It is a kind of code which is called as byte code. Then no operating system can understand this. But what is our final goal? What is our final aim? The computer should understand, the operating system should understand. It should be in machine code so that operating system will execute and gives us the output. But this seems impossible here. That means, are we saying that we need another compilation or another translation in order to convert it to machine code? Yes, if you are thinking that way, that is right. Then here we have something, again another translator, another folk called as interpreter. Then interpreter convert this file to machine code, and then your operating system execute this to give you the output. Then you can ask here, then sir, what is the benefit of this? Here we are directly compiling and then executing, getting the output. Here we are compiling and we are interpreting, then operating system executes an output. Don't we think it is a little bit lengthy process than this? Yes, it is little bit lengthy, and of course it is taking little bit more time than C and C++. Now yes, Java program is little bit so slower than C, C++ due to this intermediate action. That means this is the byte code, which is special kind of code to conversion to machine code, and this byte code is specially designed for the Java interpreter. Apart from this Java interpreter, nobody in the world can understand this byte code or dot class file, right? This interpreter is known as popularly JVM, which is nothing called as Java Virtual Machine, which is nothing but Java Virtual Machine. It is called as Java Virtual Machine. Achha, first of all, I think all of you know interpreter, the college time, compiler, interpreter. Compiler compiles a lot of lines at a time, page by page, whereas interpreter does the conversion line by line. Suppose I want to compile this set of code, compiler will translate it once, but interpreter first this line, then this line, it translates. That is what it does, and it converts to machine code. So that then of course you can clearly say that then interpreter is slower than compiler. Yes, interpreter is slower than compiler, and here it also little bit slower than C, C++. But there is some objective by making this additional step. That is what is platform independent, and you'll get to know next. We executed this thing in Windows operating system. Let's say I want to execute the same thing in Linux operating system. Same thing, Java is also portable. No need of writing source code. You can directly take it by some external media or in a transfer device. Then what you did? You did here compiler. You did here compiler, and it produces hello dot class file. Then same steps. Then it is interpreter. Then it is machine code. Then it is your operating system. It gives output. Then same comparison. Source code in both the operating system same. Output in both the operating system is same. 2 is an even number. In Windows, whatever logic, if suppose you will write, it will print even number. For Linux also it will print even number. And suppose you will printing hello world. In Windows it will come also hello world. In Linux the output will be also hello world. That means this hello.java source code or program and output same. Let's see what other same. Surprisingly, this hello.class is same here. That means whatever content and file we get after the compilation of Windows operating system for this program, same content we will get in Linux if we compile the file. That means are you saying, you can say, I can directly take hello.class from Windows and I can interpret this in Linux and I will get the output. That means I don't have to write and compile the program once again in Linux. Yes, you are absolutely right. You don't have to again recompile the code in Linux machine. That means you write in Windows, compile is in Windows, whatever file you got in Windows, get that file to Linux, directly you can execute that. That means this concept is known as ORA. What is ORA? Write once, run anywhere. Actually, it should be compile once, run anywhere, because almost languages are portable, writing once only. You can directly take it, that source file. It should be compiled once, run anywhere, but anyway, it is write once, run anywhere. That means I will write a program in Windows system, I will compile it, and I will take this compiled file to Linux operating system, Mac operating system, any kind of mobile devices, Android platform, anywhere you can execute this file, provided that system should have this interpreter. Now I think all of you clear about this platform independent nature. What is platform independent? It is operating system independent. In one operating system we can write and compile, and that compiled file, .class file, we can take to any other platform and directly execute without recompilation. Okay, good enough. Now observing the diagram, this interpreter JVM, you can say, sir, this interpreter JVM, I think, what about this fellow? This fellow is platform dependent or platform independent? It's a very good question. If you understood clearly, you can easily say this interpreter or platform, it is platform dependent. How? A simple thing. I will write a hello.java file, then I will compile this file, which is generate hello.class file, and I can execute this file in Windows operating system, in Linux operating system, in Mac operating system, in Solaris operating system, in XYZ operating system. But from above we understood here that machine code for Windows is different, machine code for Linux is different, machine code for Mac is different, machine code for Solaris is different, and machine code for XYZ is different. That means there should be specific interpreter or JVM which convert this hello.class file to Windows machine code, then this hello.class file to Linux machine code, then this hello.class file to Mac, likewise this. That means each operating system is having their own JVM, so that this common .class file will be converted to okay, their own understandable machine language, right? That means here we can say a line Java is platform independent, but JVM is platform dependent, but the JVM is platform dependent, right? So now the question is, what is this JVM? JVM is stands for Java Virtual Machine. JVM stands for Java Virtual Machine, which is nothing but Java interpreter, which is nothing but Java interpreter. First of all, what is a virtual machine? Why it is called as a machine? Generally, in almost all means maximum languages like C, C++, whatever compiled file generated, that is understood by operating system directly. That is understood by operating system directly. But in Java, whatever content produced after the compilation, that is here understood by this interpreter, just like operating system doing for other languages. If we can see here, it is hello world.c. It is compiled, then it generated the machine code, and this machine code is understood directly by the operating system. But here in Java, whenever it is compiled, it generates a special type of class called hello.class file, special type of file, and this file ideally should be understood by machine operating system. Ideally should be understood by the operating system, but it is designed in a different way that this file is only understood by this interpreter, which acts as operating system here. That's why it is called like the virtual. Virtual means not real. It is called as the Java virtual machine. So now we are clear about what is platform independent. Platform independent means writing the code and compiling the code in one platform or operating system, and then taking out that compiled file and execute in any other platforms or operating system. That is what is called as platform independent, and which is also known as ORA, write once, run anywhere. And we also got to know that Java, though Java is platform independent, JVM is platform dependent. Likewise, JDK is also platform specific. So make sure whenever you are installing JDK for a system, you should mention the operating system. So let's have some Q&A session. First question here: which of the followings are true? Which of the followings are true? A. Java is platform independent. B. Java is platform dependent. C. JVM is platform independent. D. JVM is platform dependent. Can you tell me which of the followings are true here? If you understood clearly the concepts, you should easily say. First, Java is platform independent. Yes, it is correct. So correct answer is first A. Remember, question is which of the followings. Java is platform dependent? No. JVM is platform independent? No. JVM is platform dependent. Yes. Answer is B. Next question. Java compiler is platform independent? Just true, false. True, false. So what about Java compiler? Platform dependent or independent? Answer is Java compiler is platform independent. So answer is A. I think all of you understood the concept of platform independency and how it is differing from C, C++, and other kinds of application. What is JVM? What is Java interpreter? Like that. Thanks for watching the video.